Hello everyone, I am Prashant Kumar, pursuing Information Science and Engineering at Sri Venkateshwara College of Engineering, Bangalore, 5th semester. Today we are going to discuss about the topic Transaction Processing and System Concepts from the subject Database Management Systems, subject code 21CS53. Now having a look through the table of contents where we are going to discuss about transaction processing, single user versus multi-user, two sample transactions, transactional states, properties of transaction. Introduction. In this section, we discuss the concepts of concurrent execution of transactions and recovery from transaction failures. Then we compare single-user and multi-user data systems and demonstrates how concurrent execution of transaction can take place in multi-user systems. We define the concept of transaction and present a simple model of transaction execution based on read and write database operations. This model is used as the basis for defining and formalizing concurrency control and recovery concepts. The uses informal examples to show why concurrency control techniques are needed in multi-user systems. Finally, we discuss why techniques are needed to handle recovery from systems and transaction failures by discussing different ways in which transactions can fail while executing. Transaction processing. The concept of transaction provides a mechanism for describing logical units of database processing. Transaction processing systems are the systems with large databases and hundreds of concurrent users executing database transactions. Examples of such systems include airline reservations, banking, credit card processing, online retail purchases, stocking markets, supermarket checkouts, and many other applications. These systems require high availability and fast response time for hundreds of concurrent users. We define the concept of transaction, which is used to represent a logical unit of database processing that must be completed in its entirety to ensure correctness. Single user versus multi-user systems. A DBMS is a single user if at most one user at a time can use the system, and it is multi-user if many users can use the system and hence access the database concurrently. Single user DBMS are mostly restricted to personal computer systems. Most other DBMS are multi-user. For example, an airline reservation system is used by hundreds of users and travel agents concurrently. Multi-user can access databases and use computer systems simultaneously because of the concept of multi-programming, which allows the operating system of the computer to execute multiple programs or process at the same time. A single central processing unit can only execute at most one process at a time. However, multi-programming operating systems execute some commands from one process, then suspend that process and execute some commands from the next process, and so on. Parallel processing. If the computer system has multiple hardware processors, parallel processing of multiple processes is possible, as illustrated by the processors C and D. Most of the theory concerning concurrency control in databases is developed in terms of interleaved concurrency. So for the remainder of this chapter, we assume this model in a multi-user DBMS. The stored data items are the primary resources that may be accessed concurrently by interactive users or application programs which are constantly retrieving information from and modifying the database. Two sample transactions. When a database access program is written, it has the flight number, the flight date, and the number of seats to be booked as parameters. Hence, the same program can be used to execute many different transactions, each with different flight number, date, and number of seats booked. For concurrency control purposes, a transaction is particular execution of program specified on date, flight, and number of transactions. Execution of the programs that refer to the specific flights whose number of seats are stored in data items X and Y in the database. Lost update problem. This problem occurs when two transactions that access the same database items have their options interleaved in a way that makes the value of some database items incorrect. Suppose the transactions T1 and T2 are submitted at approximately the same time and suppose that their operations are interleaved, then the final value of item X is incorrect because T2 reads the value of X before T1 changes its database, and hence the updated value resulting from T1 is lost. Temporary update problem. This problem occurs when one transaction updates a database item and then the transaction fails for some reason. Meanwhile, the updated item is accessed by another transaction before it is changed to its original value. So this figure shows an example where T1 updates item X and then fails before completion. So the system must roll back X to its original value. Before it can do so, however, transaction T2 reads the temporary value of X, which will not be recorded permanently in the database because of the failure of T1. Incorrect summary problem. If one transaction is calculating an aggregate summary functions on number of database items while other transactions are updating some of these items. So the aggregate function may calculate some values before they are updated and others after they are updated. For example, that a transaction T3 is calculating the total number of reservations on flights, meanwhile T1 is executing. If the interleaving of operation occurs, the result of T3 will be off by an amount of n because T3 reads the value of x after n seeds have been subtracted from it, but reads the value of y before those n seeds have been added to it. Transaction states and additional operators. A transaction is an atomic unit of work that should be either be completed in its entirety or not done at all. For recovery purposes, the system needs to be kept tracked when each transaction starts, terminates, and commits or aborts. Therefore, the recovery manager of the DBMS needs to keep track of the following operations: begin transaction, read or write, end transaction. Where this marks the beginning of transaction, this specifies read or write operations on database items that are executed as part of transaction. This specifies that read and write transaction operations have ended and marks the end of transaction execution. So here is a simple figure which demonstrates transaction states and its additional operators. So as shown in the below figure shows a state transition diagram that illustrates how a transaction moves through its execution states. A transaction goes into an active state immediately after it starts execution, where it can execute its read and write operations. While the transaction ends, it moves to the partially committed state. At this point, some types of concurrency control protocols may be additional checked to see if the transaction can be committed or not. Also, some recovery protocols need to ensure that a system failure will not result in inability to record the changes of the transaction permanently. So if these checks are successful, the transaction is said to have reached its commit point and enters the committed state. Properties of transaction. Transactions should possess several properties, often called the ACID properties. They should be enforced by the concurrency control and recovery methods of the DBMS. So the following are the ACID properties. Atomicity. A transaction is an atomic unit of processing. It should either be performed in its entirety or not performed at all. Consistency preservation. A transaction should be consistency preserving, meaning that if it is completely executed from the beginning to end without interference from other transactions, it should take the database from one consistent state to another. Isolation. A transaction should appear as though it is being executed in isolation from other transactions, even though many transactions are executing concurrently. That is, the execution of transactions should not be interfered with by any other transactions executing concurrently. Durability or permanency. The changes applied to the database by a committed transaction must persist in the database. These changes must not be lost because of any failure. The atomicity property requires that we execute a transaction to completion. It is the responsibility of the transaction recovery subsystem of a DBMS to ensure atomicity. Conclusion. In this presentation, we have discussed about the DBMS concepts of transaction processing. We introduced the concepts of database transaction and the operations relevant to transaction processing. We compared single-user systems to multi-user systems and then presented examples of how uncontrolled execution of concurrent transactions in a multi-user system can lead to incorrect results and database values. We also discussed the various types of failures that may occur during transaction execution. Next, we introduce the typical states that a transaction passes through during execution and discuss several concepts that are used in recovery and concurrency control management. And finally, the last, we discussed about the properties of transaction processing. Thank you.